In this video, I introduce model-agnostic meta-learning. Meta-learning is a learning-to-learn algorithm that trains a pre-trained large language model on a variety of tasks, such that the pre-trained language model can solve new learning tasks using only a small number of training examples. The parameters of a language model are explicitly trained such that a small number of gradient steps with a small amount of training data from a new task will produce a good generalization performance on that task, as shown here. Given a pre-trained language model AlphaSet, model-agnostic meta-learning algorithm optimizes for representation set that can quickly adapt to new tasks without overfitting. Suppose that the pre-trained language model AlphaSet maps the observation X to output A. Each learning task shown here consists of a loss L of the training examples, a distribution Q X1 over initial observation X1, a transition distribution Q from xt to xt plus 1, and episode length H. Tasks used for meta testing are held out during meta training. When a language model alpha theta adapts to a new task Ti through gradient update, the new model parameters theta I prime is updated by using this formulation as shown here, where alpha is the step size for meta learning and LTI is the loss of the text Ti, which is generated by model AlphaSet. The model parameters are trained by optimizing for the performance of alpha theta I prime with respect to theta across the text sampled from text distribution P, as shown here. The meta optimization is performed over the model parameters theta, whereas the objective is computed using the updated model parameters theta prime. The goal is to optimize the model parameters theta such that a small number of gradient steps on a new task will produce a maximally effective behavior on that task, as shown here. The meta optimization across the tasks is performed via stochastic gradient descent, such that the model parameters theta are updated as here and shown here, where beta is the meta step size. Two common loss functions used for supervised classification and regression are cross entropy and mean squared error respectively. For regression tasks using mean squared error, as shown here, where xi, yi is the input-output pair. The cross entropy loss for discrete classification tasks is defined as here. For more details, please check with these references. Thank you.